We're now going to solve an applied problem using inverses just to show how this can be incredibly useful to us. So we're going to start with a particular problem that involves a pendulum. And a pendulum is like on a clock, and it swings back and forth. And the period is the amount of time it takes to swing one way and then swing back to its original position. And that period depends on its length. The period t in seconds of a simple pendulum is a function of its length L in feet and is given by this equation or function. So the first thing that we're going to do is we're going to find its inverse. And I'm going to do this a little bit differently than that. Instead of swapping the variables because they're not x and y, I'm going to leave them in place, but I'm going to solve for L instead of for t. So we're going to start with t equals 1.11 square roots of L. We're going to divide both sides by 1.11. So t over 1.11 equals the square root of L. We'll square both sides, and using the properties of exponents, that gives me t squared over 1.11 squared, which is 1.2321, equals L. And so this, then, is my inverse function, which says if I know t, it'll give me the L. So I can either start with an L and get the t, or I can start with the t and get the L. Well, part B says use the inverse function to calculate the length of the pendulum, assuming that it has a period of 2 seconds. So in this case, we're going to say t equals 2, and we're going to use this equation to find it. So we get 2 squared divided by 1.2321 equals L. So we get out a calculator, we do 2 squared divided by 1.2321 gives 3.246. We're going to round that to just one decimal place. So in this case, L is 3.2 feet. So 2 seconds has a length of 3.2 feet. Part C talks about the world's longest pendulum. It's in the convention center, well, the United States' longest pendulum is found in Portland, Oregon in the convention center. The pendulum's length is 70 feet, so now we're told that L is 70. So to find the time, we simply plug this in, times the square root of 70, so we get out our calculator, we move it out of the way. We get 1.11 times the square root. Notice there's not a good square root symbol, so I'm going to use the power. 70 raised to the parenthesis 1/2 power. Remember, that's the same thing as a square root. Hit equals, and it tells me that it has a period of 9.3, going to one decimal place again, 9.3 seconds. So by plugging it into my calculator and using the correct one, I can find the other one. And so that's one example of how inverses are useful. They allow us to work things both directions.